have a limited amount of time here, and I want to make sure that this is a useful presentation for everyone. I'm sure that most of you have said this very statement at some point or another in your experience in the last couple of years as Wisconsin's Department of Military Affairs seeks to implement Next Generation 911 without the GIS knowledge that they really need to have in order to sort of move forward. Now, this is not unique to Wisconsin. 911 people don't understand GIS, and nor would I expect them to. But the great thing about Wisconsin and the land information officer construct that's in place there is that you guys are already GIS experts, even if you haven't been working with your public safety partners. And so as they seek to kind of get through this period of transition, you're in a great position to help them. Now, personally, I came from a role very similar to the one that you're describing, working for city governments and regional government entities before I got into the 911 and public safety space. I was in very similar seats to your own. And so I have the perspective of both the local government GIS data provider as well as the 911 authority as I jumped into 911 in 2009 as a GIS manager at a 911 district communication network down in Texas. I had to navigate these things as well. So what I want to do today is start out with a little bit of GIS for the PSAP. Now, most of you are probably familiar with some of this in the introduction, but I want to be sure that we don't slide by those of you who aren't. So in the PSAP, and when I say PSAP, I mean the Public Safety Answering Point, the 911 call center, if you will. GIS data has been used where there is mapping elements present. And the PSAP, they call it the MAP, right? The CAD system, the computer-aided dispatch system that has a mapping element, probably has used your GIS data, whether you've been involved with it or they just get it from you and toss it to the black box, that perhaps their vendor is taking your GIS data and making it into a map for their dispatch system. So you may be familiar somewhat with the use of GIS data in a CAD mapping system, but what NextGen 911 brings to it is the other side of the golden line. That golden line is the point at which the call is delivered and the dispatcher picks up and says, 911, what's your emergency? In a next generation 911 network, up in an in-state next generation 911 network, it's going to use GIS-based road center lines, address points, and boundaries, such as PSAP boundaries, such as fire service boundaries, law service boundaries, EMS service boundaries, and other service boundaries, to answer the question, where does this 911 call get answered? What PSAP does it go to? Now, the most ideal situation would mean that the GIS data that serves one also serves the other. And that may or may not be the case moving forward, but it's the goal that you want them to transition to. And so it's actually a decent place to start what the state did, what DMA did, in terms of getting a gap analysis of your GIS data so that you as GIS practitioners and professionals can begin to transition your GIS data from what it was built for, which was not nearly to the level of accuracy and completeness that NextGen 911 needs, so that you can transition it to a sufficient amount of accuracy and completeness that NextGen 911 needs. Geospatial routing is the term for NextGen 911 that they're going to use, that you should get familiar with. It'll do a point in polygon query to answer the question again, where does this 911 call get dispatched? Where do I need to send it so that it can be appropriately handled? Now, the system's going to look for a location in two different ways. One is the geodetic coordinate that might come from a mobile device or any device that's connected to the internet. NextGen 911 largely represents an upgrade from a copper telephone network to a wired IP-based, internet protocol-based network that allows integration and access to 911 for devices that have never before been able to call 911 and send an SOS call for service. So a lot of those devices, in fact, the majority of the devices that are going to connect to the 911 network are going to come with their own geodetic coordinate. They're going to know where they are. That point is then going to be compared against these polygons of the PSAPs, the primary PSAPs, the primary 911 centers, and answer the question, where do I send that call? In that PSAP boundary layer, there will be what's called a URN and a URI that will give the IP address of the appropriate PSAP. That's the PSAP that you, as LIOs and other local government GIS data providers, need to represent in your GIS data. The other way is a civic location is going to come. Civic locations are going to come with phone systems primarily, but other communication systems that may be IP-based as well, such as Alexa, perhaps, such as, chat applications that may be allowed to chat to 911, text to 911 in some way or another, may come with a civic location. Anything that connects to a cable modem or a fiber connected internet modem at your home, perhaps, very likely, and a static fixed location is very likely going to come with a civic location, a civic address. That is something like 1308 South Validation Avenue, Highlands, right? And it's going to be geocoded against a road center line. It's going to be searched for in your address point data set. That point is going to be determined, and then the point and polygon query occurs. Where do I send this call? We're going to send it to PSAP A over here on 1308 South Validation Highland Avenue. So it calls to the table for the 911 folks, new stakeholders, of which this audience is part. The IT departments, the planning departments, the GIS departments in Wisconsin, the LIO, are called to the public safety table in a way that they've never been called to it before. Always as sort of ancillary support. Now you become mission critical support for next generation 911. So what do I need to do? I got my gap analysis from the state. That's all fine and dandy, but what do I do with that? Where do I go? What do I need to be concerned about? I need to be concerned about gathering the information that I need to know in this phase of the deployment, because there is not an EZNet. EZNet is an emergency services IP network that the state will provide for your 911 centers, because they're in the process of getting one of those in place, procuring one in the first place. You have a window of opportunity to begin your NG9-1 readiness journey, and you need to do it by thinking about workflows and business processes, by thinking about your data availability, quality, your schema, and the data usage. Now, the part for the GIS professional that the 911 folks don't think about, shouldn't need to think about, because it doesn't necessarily impact them, is how does the increased level of accuracy and completeness, the needs that NextGen 911 places on my GIS data that other systems don't, how is that going to affect the other systems, the other enterprise systems that are using this very same GIS data? Schemas are an interesting topic. Data quality, data availability. I could go for hours talking about these things, but I've only got about 20 minutes left, so we're not going to get to go into the full level of detail on these. I will on Thursday be back with a discussion about data quality, and we will get to nerd out about that just a bit. So some more information gathering. You need to start realizing, you need to start documenting if you haven't already. You probably have done a great job of that because you have this robust LIO system in place. But thinking about what are the processes, the business processes, the data processes, and the workflows that bring this data into my GIS data set, and what are the processes that I'm going to need to put in place to get it out of my GIS data set and in the right format. Now, addressing is a great example that I'm going to use to sort of demonstrate the type of information you need to gather. Now, it varies based on the type of county you work for, the type of municipality you work for. How many addressing authorities do I have? What is the process of addressing? When does an address become an address? When is it preliminary? When is it retired? How does it get assigned? When does it get entered into GIS? What if discrepancies come up? This is all part of a process. I'm not here to give you answers as to how to construct those processes, but it's a great example of a process that really needs to be thought through. Not only addressing, but road center lines. When boundary annexations occur, you've probably already got processes for all of those things. However, you need to start thinking about, how do I need to adjust these processes to also include public safety stakeholders in review, to be sure that the addresses, the road center lines, the road naming, the address range assignments make sense to public safety if you haven't already done so? How do I need to include an output, an export? Do I need to set up a new extract, transfer, and load, an ETL, to get it out of a maintenance schema with lots of other stuff that aren't relevant to an NG9-1 into an NG9-1 schema? How do I build a quality assurance culture? Everybody wants quality assurance culture in GIS that is concerned with the proper data quality, so that when I export that data out of my maintenance schema, I can actually export it into, to go back to coordinate systems, the WGS84 coordinate system the next Gen 901 elements are going to need. I don't need to maintain it in that, but I need to every once in a while export it and just do some quality assurance on that. Make sure that things are shifting the way I expected them to shift, and that locations are accurately portrayed to the extent necessary. This is the kind of information gathering you need to start doing ahead of time. And as you step into that 911 readiness journey, you need to pursue what I refer to as a purposeful order, or a purposeful path. You want to think about, what's the right path for me? Now this represents this path that I lay out here represents a purposeful path for a generic case. These are some things that ought to be considered about that path. First of all is an MSAG to consent centerline comparison. If you're not familiar with an MSAG, it's a master street address guide, a legacy 911 database that is tabular in format and has been managed on an island by public safety for the purposes of routing those copper wire telephone calls in the past, and well, in the present. That MSAG is roughly equivalent, very roughly equivalent, but not one-to-one to your road center lines. It's concerned about the road name and the address segments that fall within a given emergency service number or emergency service zone, which defines which PSAP would answer that call. And so if you're not familiar with an MSAG or haven't seen one, I recommend that be part of your information gathering as well, because one of the first steps I would recommend is a comparison between the two. Now, the gap analysis that you got probably did a little bit of comparing of your MSAG to your road center lines. And so there is where that data may be useful to you. It may or may not be detailed enough to tell you what you need to fix, but it will give you a picture of the magnitude of which the efforts need to be put into place to address issues. The Master Street Address Guide example here on the top demonstrates what a Master Street Address Guide is. As I mentioned, with a low and high range of addresses, the address name components of a direction, street name, community, state, AESN number, as I mentioned, it tells who answers that 911 call, and a whole lot of other stuff that telephone companies are concerned with, but don't really relate to the actual location of things. The address ranges are there, ESN, and that's what it contains. So there's a lot to the process of taking an orange, and let me just take a minute to say this. The orange that is the MSAG and compare it to the apple that is your GIS data. So you need to be able to figure out how to make the apple into an orange so the orange can be compared to an orange that's based on your GIS data. That wasn't too confusing through the fruit kingdom there, but that's the effort of this comparison to make. Out of that comparison, you can begin to get a sense of your boundaries as 911 sees them. Again, creating an apple out of an orange, your boundaries as 911 sees them is a great thing to compare to your boundaries as you, as the GIS professional, see them. Where do they differ? Where have in most cases, the MSAG not kept up with the annexations that have occurred and been documented in your GIS data. In other cases, there's stuff in GIS data that didn't necessarily relate to the boundary of an emergency responder, of a law enforcement agency, a fire agency, an EMS agency, because there are many things that define those boundaries outside of the administrative boundary of a city, county, or any other political entity. And so those are generally a great place to start with boundaries, but they're not the only thing that would inform a boundary. And here's some examples of the types of boundaries that would go into that consideration. The administrative boundaries, as I mentioned, are a good start, municipalities as well. In the end, you're looking to create this PSAP boundary and these emergency service boundaries here, fire, law, and EMS, as three good examples. That represent where a phone call needs to be delivered in a primary sense and where a phone call needs to be transferred in a secondary sense. There's a whole discussion about boundaries that is to be had about quality, about accuracy, and about completeness of boundaries as well that I don't have time to go into, but boundaries are critical and important and have to be thought about in the path, the purposeful path. You see those boundaries begin to lay over. One thing you have to avoid, and it's an oversimplification to say there should be no gaps in your boundaries. However, there should be no unintentional gaps in your boundaries. Between all of these types of boundaries, there cannot be gaps that are not known and explainable and intentional without routing problems. Again, in the example here, this geodetic coordinate of a mobile device will plot right into this, right up against the boundary. And if it doesn't find an answer, it's going to have to do what's called default routing, which may lead to extra transfers and extra time and potentially threaten citizen safety and livelihood. The third step that I want to recommend in this general purposeful path is location data normalization. Now, I love this audience because I say location data normalization, and I bet you all instantly have a conception of what I'm talking about. When I speak to many other audience, that I have to do a lot of explaining. But what I mean by that is that there's a lot of normalization that should occur in data sets, such as here, where the non-normalized values over here of the abbreviations for avenue, including the fat finger misspellings, have to be normalized into a spelled out version. Now, again, it doesn't have to be maintained this way, but you want to maintain at least the normalized version of that abbreviation. And then as your ETL export goes out, it gets transformed into the spelled out version that is standard compliant. Data consistency is another factor of this location data normalization phase, where you want to be sure that address points, you're doing normalization between data sets, right? Between the road center line and the address points. You have an example of a graphic here of what fishbone analysis can do for you in this phase of your work, location data normalization, where you examine the relationship of the placed address point to the geocoded point along the road center line where that same address is found. And you can check for discrepancies, usually fat fingers, usually misapplied address ranges, things like that that cause trouble. Those fishbones can help you find that. Again, on Thursday, I'm going to go through a detailed discussion of data quality, but you need to be concerned about the availability of the data that you need, the completeness of the data set. Is it going to meet the needs of NG9 1-1? The accuracy of the data set, not only spatially accurate, but among attributes accurate and normalized in that third step. And that it's maintained in a timely way. There are recommendations that would require, if you were to adopt them, a 3 business day turnaround for any kind of discrepancy that comes up. Most existing GIS data business processes are not built for that kind of resiliency and timely response. Ultimately, what you're looking for as the GIS professional, and the benefit to you is that you get this high grade, beautiful data for consistent use among all your enterprise systems, not just for NextGen 911, but also as it relates to your assessor systems and your planning systems and your public works systems, as it relates to permitting systems and other systems that may use GIS data. Everything can use solid location data as base. And that's what address points, road center lines, and these boundaries can form. Again, stay tuned for that on Thursday. We'll get right into the weeds with data quality. Finally, if you can compare a data set called an ALI, the Automatic Location Information System database, that is a legacy 911 database in the tabular format that represents subscribers that will likely be sending civic address locations instead of geodetic locations into that emergency call routing function in NextGen 911. If you can compare that automatic location information or the ALI database to your GIS data, and you can say with confidence that your GIS data is substantially aligned with the ALI database. In other words, those ALI records and the addresses in the ALI database geocode in a substantial way to my GIS road center line or to my address point layer or both, then you can say that you are ready with GIS data that will be effective and functional in the next generation 911 geospatial routing system. Now that ALI to GIS comparison was part of your, undoubtedly was part of your gap analysis and what your gap was. You're gonna need to shoot for 100%, but it's not always possible to get 100% there. Sometimes there's things in the ALI that you don't need to have in your GIS data. Sometimes there's things that you need in your GIS data that aren't going to be represented in your ALI. So that's a whole deep dive discussion as well. But this is the metric by which you can say with confidence, my GIS data is ready to be used in the next generation 911 geospatial call routing system. Then as it relates to, oh, this is the example of the ALI, sorry about that, I need to show you this. The point, does it geocode the way it should? Right? Is it in the right location? And are the ESNs represented in your GIS data the way they should be? That lines up with that ALI. Right? It's going to find them in the address point layer as well as against the road center line. That's an important and critical verification point as well. Fifthly, you're going to have to think about your workflow process, and finally on this purposeful path, your workflow process for data maintenance. Right? You've already got data maintenance processes set up because you're here. The LIOs are already maintaining data. Some are maintaining these road center lines address points, some are not. But you're going to have to think about what does the data maintenance process need to look like to maintain high quality data, complete data in a timely way, in a rinse, wash, and repeat fashion, right? It's going to take some definition of stakeholders and relationship building that perhaps you haven't done up to this point with public safety partners. It's important that you pursue those relationships, and the message goes back to the 911 folks as well. It's important that they pursue relationships with their GIS professionals. Otherwise, there will be this sort of throwing of data over the wall back and forth, and when things go wrong, it's going to get real ugly real quick. So define those relationships, establish the data sources of your authoritative data set, of your data sets, authoritative data sets. Do the data creation efforts that you need to do to get it up to speed. Post gap analysis, the gap has been defined for you in some way or another. Now you get to work creating the data that you need to create, updating the data that you need to update, validate for quality to undertake your quality assurance processes, remediate with stakeholder groups, publish that data, and maintain this rinse, wash, repeat process. Let's see, 3:12. I got just another few minutes. Good. I'll be able to finish on time today. So there's lots of different considerations to take based on where you're at. I got my gap analysis. What do I need to do now? Well, the answer to that question relies on the answer to the question, where are you at in the process? No matter where you're at in the process, you need to undertake or maintain communication with the right parties and people in the process. From a GIS perspective, you need to start considering the data quality aspects that are required by Next Generation 9-1-1. Maybe you need to read some standards. Maybe you need to read schema models and the GIS data model that's put out by the state, right? DMA provided with a GIS data model that interprets the NINA model into what Wisconsin needs at this point. You'll need to think about what are the implications of that DMA standard on your local schema? What are the implications of keep maintaining data to that DMA standard going to have on your downstream uses of that same data? How do I set up a maintenance schema that allows me to manage data in maybe a couple different formats and export then ETL that same data into the right format for DMA, the right format for my public works users, the right format for all those other systems as well. You'll want to start creating documentation about these processes that you're finding out, the standard operating procedures necessary to maintain data and get it up to speed as necessary. You'll need to start having a conversation with the elected officials, with the executives that are making funding and financial decisions. You may need some more resources. It may be that you need some resources out of a 911 budget. You may have to start having that conversation. You may need some additional IT resources. You may need new software, new hardware to create the necessary data for this necessary upgrade of the public safety 911 system. And finally, you may need some additional training. You will need some additional training. Let's not make any ifs, ands, or buts about it. You will need training. You'll need to understand some of the public safety systems. You'll need to understand the standards that are out there. You'll need to be able to interpret with thoughtful intentions these standards and figure out how it works within your systems and setup. And ultimately, this is all a call to action, right? To do the things around governance, around roles and responsibilities, around process workflows, creating agreements where necessary to the level of formality that are appropriate, and considering what you need to do to move your GIS data into a condition it needs to be in order to be used for next generation 911 geospatial call routing. So I won't say it again, but I'll leave this with you. Here's my action items for everyone here. Build the relationships, define the governance, get ready for readiness effort and maintenance. Make that purposeful path. That's what you can do with your gap analysis. It's easy enough to think about that gap analysis as a very granular technical document, but you need to pull your thinking not only in that document, but also above it to think about all these other things as well. So I really appreciate the opportunity to be here with you and share it with you today. Again, as I mentioned, Thursday, I'll be on talking about the GIS data quality. My focus will be GIS data quality as it relates to Next Gen 9-1-1, but it's going to be very useful and thoughtful in terms of GIS data quality in general. So I look forward to being back with you on Thursday.